A paired samples t-test compares the mean value of a scale variable at two different points in time. So it's the same people, the same variable, two different points in time. And this could be a pre-test, post-test type scenario. The assumptions of a paired samples t-test include that the sample is recruited randomly, that the test variable is scale level of measurement, that the values of the test variable are dependent or paired, that is, if someone is in one group, they are also in the other, time 1 and time 2, and that there's a large sample, 30 or more observations, or that the scale variable you are testing is normally distributed. Mean pulse significantly different at time 1 and time 2. So in this data set, we have a group of students. They took their pulse at the beginning of class, and then they had an intervention of running in place. And then they took their pulse again after the intervention, and now we want to compare their pulse at time 1 and time 2 and find out if they're significantly different. So we're going to use the data set called Pulse, so get that into your class stat folder, then run your libname statement, and then we can go ahead and conduct the paired samples t-test by starting out with proc t-test. Data equals class stat, the folder that it's in, pulse, the name of the data set, sides 2, alpha equals 0.05, and our null hypothesis HO is 0, meaning that we don't expect there to be a significant difference between the two groups, a 0 difference. And then in the second line is paired, and then the paired variables. So pulse 1 is pulse at time 1, and pulse 2 is pulse at time 2. Semicolon, run, and run. And now we have our results here. We have some descriptive statistics to begin with, and then we have a p-value, and this is the p-value we interpret, and since it is less than alpha, we can reject the null hypothesis and conclude that there is a significant difference in pulse between time 1 and time 2. And so here is the difference in pulse between time 1 and time 2. So we can see that it's 21 beats per minute lower at time 1 compared to time 2, which is what we would expect. That pulse would be lower before the running intervention compared with after. And so this is the sentence we could write to interpret our findings, and remember to include the t-value, the test statistic, and the p-value at the end.